This lesson is going to review our chapter on the organization of the periodic table, and we're going to start with the families. So there are several families that you need to know where they're located and some general properties about them. The first is the alkali metals. These are located in group 1, so it's everything under hydrogen, not including hydrogen. The second group is group number 2. These are called the alkaline earth metals. In the middle, we have the transition metals. So these are in the D block. Way over on the right, we have noble gases. And next to those are the halogens. So make sure you're familiar with where those families are located. The second thing you need to know are some general properties about them. So you should know that both the halogens and the alkali metals are very reactive. Both of these families only need to gain or lose one electron, and it's pretty easy to do that, which makes them react pretty violently. The noble gases are not very reactive. They are already stable, they have all the valence electrons they need, so they're not likely to react. You can force them to, but they're not going to on their own very often. The next thing you want to be familiar with is oxidation numbers, so make sure you can label these as +1, +2. Skip over the D block and it goes +3, plus or -4, -3, -2, the halogens are -1, and then 0. So make sure you have your periodic table labeled with those oxidation numbers. And oxidation numbers are just the charge that they tend to become when they gain or lose electrons. There's a few vocab words you need to be familiar with. Up and down is called a group or family. Horizontal is called a row or period. And it's a little confusing because if I ask you what row isn't something in, you're actually going to count down. It's the left and right horizontal rows, so then you would count down to see how many it's going to be. The next thing we want to do is compare metals to metalloids and nonmetals. You need to know, first of all, where they're located on the staircase. So the metals are located to the left of the staircase. Nonmetals are located to the right of the staircase. And metalloids are located on the staircase. There are a few exceptions. So hydrogen is a nonmetal. Even though it looks like it's a metal, it's to the left of the staircase. And aluminum is a metal, even though it's not, it looks like it's a metalloid. Then you need to know some properties of these. You need to know that metals are shiny, they are ductile and malleable, and they conduct electricity well. And that's because of that sea of electrons. You need to know that nonmetals are pretty much the opposite. So they are dull, they do not conduct well, and let's go ahead and put the charges for each of these two. So these tend to be positive, and these tend to be negative. And then the last ones are the metalloids, which we consider to be semiconductors, because they can conduct better than nonmetals, but not as good as metals. And then the only other thing you need to know for this is the trends. And there are several trends that we talked about, but before we do the trends, it's important that you know the definitions for these long words. So we talked about ionization energy. Ionization energy is the energy required to remove an electron. So in this one, we're talking about removing those valence electrons. And then the other big, long, fancy science word we did was electronegativity. And this is the ability to attract electrons. And it's kind of specific, it's when it's in a bond, but we're just going to focus on attracting electrons. And these actually both have the same trend. So even though they're opposite ideas, because of the wording of the definitions, they end up with the same trend. So here's our periodic table. There are two trends that increase towards this bottom left corner. And that is the radius, which is a fancy way to say the size of the atom. So atoms are going to increase as you go down a column because you're adding energy levels, and they're going to decrease as you go left to right because you're adding protons. And just as a side note, any of the trends up and down has to do with energy levels. So remember, we add energy levels going down, which is why they get bigger. And then the horizontal trends are because of adding protons. As you go left to right. Okay, so the two trends that increase to this bottom left corner are the radius and then also metal reactivity. Metals are trying to lose their valence electrons, and it's easier to lose them if they're big, so the biggest metals are the most reactive. So that bottom left corner is the most reactive of the metals. And then there are three trends that increase towards this corner. Both of the big, long, fancy science words, so electronegativity and ionization energy, and then also non-metal reactivity increases towards this corner as well. And that's because nonmetals are trying to gain electrons, and it's easier to gain them if they're small. So in that top right corner, that's where the smallest nonmetals are, so they're going to gain better. However, only two of these three trends actually go all the way to helium. Let's draw this real quick. So the only trend that goes all the way to the top right corner is ionization energy. Both electronegativity and nonmetal reactivity stop at fluorine because the noble gases are never going to attract electrons regardless of how big they are. So they're going to have a low electronegativity, and same with reactivity. We already said that they're not very reactive, so it's going to increase up and to the right until you get to fluorine. The only one that goes all the way to this top corner is ionization energy. And the last thing for this chapter is you need to know about the size of ions. So when you gain electrons, meaning it becomes bigger, meaning it becomes negative, it actually gets bigger because those electrons are going to repel each other. And when you lose electrons, meaning it becomes positive, it's going to get smaller. So if you're comparing, for example, chlorine to chlorine negative is bigger because it has received an extra electron. But if you're comparing sodium to sodium positive, the neutral one is bigger, because becoming positive makes it smaller because it loses electrons. And that is it for periodic table.